Hello Year 9, as promised in this video I'm going to work through the challenge question that I showed in class during our lesson on finding the surface area of prisms. So here we have a trapezoidal prism, and what makes this question challenging compared to the other worked examples we looked at is there is one side whose length we need to know to calculate the surface area, but we don't know the length, and that's that side I've just highlighted here in yellow. Because without knowing that length, we can't work out the area of the trapezoidal face, and we can't work out the area of the top rectangle. Go! So before we can go through the process of calculating the surface area as the sum of the areas of the individual faces, we need to do a preliminary calculation to work out this side length. And what we can do to help us is if we overlay a vertical line going from the top corner of the trapezium down to its base. So that's a perpendicular line, so the base angle will be a right angle. What we get is a right angled triangle of which two of the three sides are known. And the reason we know two of the three sides is we know that the opposite sides of a rectangle are equal. So that means this length and this length will be equal. So the vertical length of the right angled triangle will be 12. And we know this length and this length will be equal. So the hypotenuse will be 13. So the only length we don't know is the bottom length of the triangle x. And whatever that length is, if we take 16 minus x, we will have the remaining length of that bottom side of the trapezium, which matches the unknown length that we need because, again, opposite sides of a rectangle are equal. So maybe I'll call that y. And let's now do the preliminary calculation to work out x and then in turn work out y. So by Pythagoras' theorem, we know that x squared plus 12 squared, the sum of the squares of the two shorter sides, will be equal to the square of the longest side, the square of the hypotenuse, which is 13. So x squared plus 12 squared is 13 squared. 12 squared is 144, so x squared plus 144 is equal to 13 squared, which is 169. I can then subtract 144 from both sides. I'll get x squared equals 25. I can then take the square root of both sides, and I'll have x is equal to 5. And here I only take the positive square root because I'm only focused on the length of a side of a shape, and so we don't really deal with negative lengths. So now that I know x is equal to 5, I can say y is equal to 16 minus 5, which is equal to 11. So now I'll just erase all of these annotations because now I can overlay the unknown length that we need, which is 11 centimeters up here at the top. Now that we know that, we can go through the process of working out surface area. It will simply be the area of each of the individual shapes that are around the outside of this prism. So what I might do is just highlight them one at a time, and we'll work out their areas and add them all up. So I'm going to start with the trapezium, which is at the front of this prism, and it's also at the back of the prism here. So what we need to do is calculate the area of this trapezium and then multiply it by 2, and that will give us both the front and the back. So I might call this the area of the front and the back. So that's going to be equal to 2 times, and the area of the trapezium is the perpendicular height over 2 times the sum of the parallel sides. So that will be 12, the perpendicular height, divided by 2 times the sum of the parallel sides. We now know they are 11 and 16. So I'll just type that into the calculator. 2 times 12 on 2 multiplied by, in brackets, 11 plus 16. So that gives us 324, and the units will be square centimeters. All right, well, I'll erase that. And now let's focus on the, let's go with the top triangle. And again, this was 11 centimeters in length. So the dimensions of this top triangle will be the 11 centimeters that we worked out, and then the 4 centimeters that we're given down here. So I'll call this the area of the top, and that's equal to 11 times 4, so that will be 44 square centimeters. Now I'll erase that, and let's do the area of the bottom. Let's go with the bottom of the prism. Another rectangle, and the dimensions of this bottom rectangle, we're told, are 16 by 4. That one I might just type in the calculator just so I don't make a mistake. 16 times 4 is equal to 64. So that will be 64 square centimeters. Okay, next we'll do the left side. So this rectangle here. So I'll call that area of the left. And the dimensions of that rectangle are 12 by also 4, because we've got this length here of 4. So 12 by 4, that will be 48 square centimeters. And then finally, just one rectangle remaining. That's the rectangle over here at the right of the prism. And the dimensions of that rectangle, the area of the right, is 13 by 4. And that one I might type in, just again, my 13 times tables aren't the best. 13 by 4, 52. 52 square centimeters. So now that we've worked out all the individual components, we can say the total surface area is equal to 324 plus 44 plus 64 plus 48 plus 52. And so let's type all of that into our calculator. 324 plus 44 plus 64 plus 48 plus 52. And the final answer is 532 square centimeters. So there you have it. That's how you tackle that challenging question. Same process as always in terms of working out the various areas of the individual sides and then adding them up. The key challenge was finding that unknown side, and that is the way in which these surface area questions can be made more challenging. You may be required to use some prior knowledge, whether it's Pythagoras' theorem or some other geometric knowledge that requires you to work out an unknown, and then you just follow the process as we have been, working out the individual areas and then adding them up. All right, hopefully you found that helpful, and tick boom.
We bring the boom, that's what we